All right, guys, today we're talking about the unit circle, and we might get to reference angles a little bit towards the end here. So you'll have a document with all of this stuff written out in it. You don't need to write down every word here, but you'll have a document that you can print out that has all of this written out. Okay, so what the unit circle is, it's a circle with a center at the origin, so this would be at 0, 0, with a radius of 1 unit. Okay, so up, down, left, and right to get to the edge of our circle is 1 unit. Okay, and the center is at 0, 0. Okay, angles, when we measure them on the unit circle, start on the positive x-axis. So we would always start over here. It's kind of the boldened in line here. And we measure our angles counterclockwise, or opposite the clock. So kind of following the order of our quadrants, like quadrant 1, 2, 3, 4, right? Same order that we named the quadrants. This is the direction we do our angles. Okay, so counterclockwise. This is called standard position, okay, of an angle on the unit circle. The side of the angle that is not on the positive x-axis, so if I measured a, say, positive 60-degree angle, and we went out here, these would be the two sides of my angle. The side that's not on the positive x-axis is called the terminal side. Right? So here's a terminal side of a positive 60-degree angle. If we went to, say, 120 degrees, we might be somewhere over here. So that'd be like a 120-degree angle. 180 would be all the way to the other side, right? That'd be a straight line, etc. And so you can go all the way up to 360, and actually you can go beyond 360. If you have a negative angle, we measure that clockwise, so going in the opposite direction. So you can see here is a negative 30-degree angle. All right, so on the unit circle, the point on our circle for any given angle in standard position will have an x and y coordinate, where x, the distance from the origin to directly underneath our point, so down here, represents the value of cosine of that angle. Its y coordinate, so it's the distance vertically here, represented over here, from our origin, is its sine value. So its height is sine, and its distance in the x direction is cosine. That's where sine and cosine values come from in your calculator. There are multiple angles on the unit circle that give us exact values for sine, cosine, and tangent, and we'll talk about tangent later. These are any of multiples of 30 and 45 degrees. Okay, these values originate from our special right triangle, the 45, 45, 90, and 30, 60, 90, that have a hypotenuse of 1. So here, when we measure these angles, we always use an angle from standard position. So we use a right angle down to the axis, and we'd be talking about this angle in my new made-up angle here. Okay, so here we're talking about a 30-degree angle from standard position. And because remember our radius, so here is our origin or center, 0, 0. Our radius is 1 on the unit circle. Our hypotenuse here is 1. So if you remember the special right triangles, the relationship between the shortest leg and the hypotenuse is the hypotenuse is twice as big as the shortest leg, where the shortest leg is 1/2 of the hypotenuse. So half of 1 is 1/2. The sine of 30 degrees is exactly 1/2 or 0.5. Now the cosine value, if you remember going from the short leg to the long leg in a special right triangle, you multiply the short leg times the square root of 3. So if we put that over 1, we end up getting root 3 over 2. So the exact value or distance in the horizontal direction here to that underneath that point that we'd get with a 30-degree angle is root 3 over 2. Okay, so likewise, if we do this for a 60-degree angle, so here we still have a 30, 60, 90 right triangle. So we still have a short leg and longer leg. This time though, our short leg is down here. So half of our hypotenuse is 1/2. And if we again multiply by square root of 3 from our short leg, we get root 3 over 2. So our x and y values have kind of flip-flopped here because our shorter and longer legs have switched. And that's the note at the bottom that x and y here in our coordinates for 30 or 60 degrees are flip-flop, because in the special right triangles, which one is the shorter leg and longer leg have switched. Okay, well here's our 45, 45, 90. So for a 45-degree angle, you might remember in a 45, 45, 90, the two legs would be equal, so we should get the same value here for sine and cosine. And if you remember this property, this is a terrible 45, 45, 90, but we'll go with it. If these two legs were equal in a 45, 45, 90, if this was x and this was x, the shortcut to get to the hypotenuse was x root 2 from Pythagorean theorem. So instead of multiplying by root 2 to get to the hypotenuse here, to go backwards to our legs, we need to divide by the square root of 2. Okay, so we're going to take our hypotenuse here and divide it by the square root of 2. Okay, and if we do that, remember dividing by something is the same as multiplying by its reciprocal. So 1 over root 2. Okay, so we need to take our hypotenuse, 1, and divide it by the square root of 2. Now, while this is an exact value, we're not supposed to leave radicals in the denominator. So we rationalize that by multiplying top and bottom by the square root of the bottom, square root of 2, which gives us the square root of 4, or 2. So root 2 over 2 is our sine value, and because these are equal, we get the same value for x. Remember, the two legs in the 45, 45, 90 are equal. So both of them, the sine and cosine at 45 degrees, are root 2 over 2. Our last trig value, tangent, okay, is actually defined as the ratio of sine over cosine. So this comes up enough that we need a third trig function. So use the exact value we derived to come up with our tangent values in the first quadrant for 0, 30, 45, 60, and 90 degrees. And here's a nice picture for you. Sine gerene over cosine gerene is tangerine. Ha 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 ha. Okay, so don't forget, if we are dividing by fractions, that we will multiply by the reciprocal, and we shouldn't leave radicals in the denominator. So let's do the easy ones. At 0 degrees, remember this is the origin here, and then we have a radius of 1, right? So for this coordinate, we have the point 1, 0. That would be our cosine and sine values. And because tangent is defined as sine of our angle over the cosine of our angle, and this symbol is just theta, it's just used for unknown angles. This is really like the y coordinate over the x, which is kind of what we'll think about for these. So y over x, 0 over 1, is equal to 0. The tangent of 0 degrees is 0. Our next easiest one would be up top here, where my coordinates are 0 and 1. That's my cosine and sine value. So again, because tangent is sine over cosine, y over x, this time we get 1 over 0, which is undefined. Cannot divide by 0. 0 in the denominator, not good. But tangent of 90 degrees is undefined. The next easiest value of tangent to derive is at 45 degrees. Remember from our previous slide that our two values here were root 2 over 2. So if we were to do y divided by x, in this case because they're fractions, we're going to write them out horizontally. It's y divided by x. But hopefully we know anything divided by itself is exactly 1. Tangent of 45 degrees is 1. Okay, for our other two values, we're going to fill in the answers we got from our other sheets. Remember here, y was 1/2. This was root 3 over 2. So if tangent is y divided by x, we're going to take our y and divide it by x. We're just going to write this horizontally since we have fractions. And remember, when you're dividing by a fraction, we multiply by the reciprocal. So these 2's will cross-reduce or cross-cancel. We get 1 over the square root of 3. But again, we're not supposed to leave radicals in the denominator. So we multiply top and bottom by root 3, and we get root 3 over the square root of 9, or 3. Root 3 over 3 is the exact value of tangent of 30. Okay, similarly, for 60 degrees, if this is 1/2 and this is root 3 over 2, and we do y divided by x, we write that out horizontally, y divided by our x coordinate, and multiply by the reciprocal, so times 2 over 1. Once again, these 2's will cross-reduce, and we get square root of 3 over 1, or square root of 3. The exact value of tangent of 60 degrees is square root of 3. So here are all of our sine, cosine, and tangent values in the first quadrant. The rest of the values in the other three quadrants can be filled in using symmetry on the unit circle. Outside of quadrant 1, though, we do need to be careful that some of our coordinates like x, cosine, and y, sine, and tangent, the ratio of those two, might be negative depending on their position in our coordinate plane. We'll learn about those more in the next video. Okay, so here's the first quadrant of the unit circle, and one of the things you're going to be asked to do is be able to fill in all of these values. So we're going to go ahead and put our angles in degrees on these dashed lines. So this would be 0. Hopefully you know this one is 90. In the middle is 45 degrees, and remember these other ones are our multiples of 30. Whoops, 30 degrees and 60 degrees. In radians, this would be 0 radians. This is pi over 2 radians. Half of pi, remember pi is 180, right? So this is half of 180. In the middle, this is pi over 4, right? Half of half, or a fourth of pi. 30 degrees would be pi over 6, because that's 180 divided by 6. And 60 degrees is pi over 3, because that's 180 divided by 3. So pi divided by 3. So there's all of our angles. We can fill in the coordinates for our 90-degree angle pretty quickly. My y-coordinate is 1, and x is 0 for sine and cosine. And here we have 1, 0. So there are lots of methods to fill in our other values here. There's some cool ones where you use 1 over 2, square root of 1 over 2, which is just 1/2, right? Square root of 1 is 1. Square root of 2 over 2. Square root of 3 over 2. And then you could even think of this as square root of 4 over 2, which is 2 over 2, or 1. So you can kind of follow a pattern of doing the square root of the top. And you could even think of this as square root of 0 over 2, right, which would just be 0. If you go backwards, this would be square root of 0 over 2. So do square root of 1 over 2, which is 1/2. Square root of 2 over 2, square root of 3 over 2. And you can think of that as square root of 4 over 2. So there's a nice pattern you can follow there to fill in some of those values. Tangent, we just need to kind of have memorized. Tangent of 0 degrees is 0. That would be 0 over 1. And up here it was undefined. At 45 degrees, where sine and cosine were equal, we got exactly 1. And an easy way to help remember the other two tangent values, they both involve root 3. But I remember the smaller angle is also divided by 3. So it's root 3 over 3. So here's what our first quadrant will look like. Okay, this last part here, I'm going to show you guys what's called the left-hand trick, where I can quickly derive sine and cosine in the first quadrant. So sorry for you lefties, this is kind of designed for people that are right-handed and you have your left hand free. So if you take your palm and face it towards you on your left hand, and you orient it like this, where you kind of make it look like it's in the first quadrant, we're going to imagine each of our fingertips as being these angles that give us exact values. 0 for your pinky, 30 for your ring finger, 45 for your middle finger, 60 for your index or pointer finger, and 90 degrees for your thumb. Okay, and we're going to use this kind of blank format, square root of blank over 2, kind of like the pattern we just showed you. And we're going to think of, just like our coordinates, x cosine is on the left and y sine is on the right, just like we would write an ordered pair. So here's how this helps you work. Okay, hopefully you're holding your palm up here to try this out. Let's say I wanted to find cosine or sine of 30 degrees. So you take your hand, 30 degrees is your ring finger, and so you're going to fold that down. Okay, so this is the finger folded down here. Okay, so if I want the cosine value, we count how many fingers are up on the left. Since cosine is the x-coordinate, it's on the left of our coordinates. And in this case, we have 3 fingers remaining up. So we'd fill in 3 here. And the cosine of 30 degrees is root 3 over 2. If you wanted to find the sine of 30 degrees, we still keep our hand in the same position, but sine, the y-coordinate, is on the right. So how many fingers are up on the right? Is just 1. So we place 1 in here. And the square root of 1 over 2 is 1/2. So the sine of 30 degrees is 1/2. So try this out. Let's say, what if I wanted to find the cosine of 90 degrees? Okay, so cosine would be your thumb, And if you fold your thumb down, how many fingers are remaining up on the left-hand side, which is where cosine would be? That is 0. So we put a 0 in here. I'd get square root of 0 over 2, which is just 0 over 2, or 0. Now, if you wanted the sine of 90 degrees, that would be how many fingers would be left up on the right, which is 4. Again, you get square root of 4 over 2, which is 2 over 2, or 1. Okay, so this is a pretty cool way to rederive sine and cosine pretty quickly. You do have to memorize that cosine's on the left, sine's on the right, and which finger represents which value. You also need to remember the template, square root of blank, which is the number of fingers up on the left or right, over 2. Right? That kind of follows the pattern we used to fill in the first quadrant. So one of the things you're going to be asked to do is be able to quickly come up with these values. A lot of people use flashcards. Some people will rederive it with this pretty quickly. But you need to know the values in the first quadrant and have them all memorized or easy to derive quickly in some way. For tangent, you may just need to memorize those. Remember, your tangent values are 1 because their sine and cosine were equal here, 0 on the x-axis, undefined on the y-axis, and the other two both involve a root 3. This is for tangent. And the smaller angle is also divided by 3. So make sure you guys have those memorized. We're going to do a bunch of examples in class, and you may have a speed test to see how quickly you can do some of these things soon. Okay, this will all be provided for you in a document where you can fill in some of the blanks as we did them. You don't have to try to draw and write all of these things.